Roosendaal. I'm an IT architect, and my main focus is on search, scalable search, and SEO. And let's see if this one works. So, what am I going to talk about? Well, I hope to be answering all of those questions. So, what is search at Bol.com? I'm going to talk a bit about ElasticSearch, what we're doing with ElasticSearch, about the challenges we hope ElasticSearch can solve. And I hope to give you a general feel about search at scale, at least what we think is scale. So there's another line of Java code in here. That's good. If you have any questions, please drop it.
Sorry. So big is the problem. Is it possible to use the microphone or speak up because there's some noise or otherwise we need to do it?
I'll try to speak up like this. I hate using that microphone because, all right. So let's first start at the beginning. So does everyone know what Bol stands for? Bertelsmann Online, right? So we started, I think, in 1989, and was sort of before as the counterpart to Amazon at that time. But at that time also the internet bubble burst, and that meant a lot of companies went bankrupt. But Bol.com remained alive, but somehow only in the Netherlands. So then we actually started in 1999 with books. That was our first category. You could sell, buy books at Bol.com. And we started to expand a bit. In 2004 we had films, music, games and software. And we started to extend to consumer electronics, TVs, etc. Toys, but also not also toys, we also started to expand to Belgium. And we also started to open up our store to second-hand sellers. Did everyone, who sold a second-hand product to Bol.com? Yeah, okay, it's not bad. Are there any sellers, professional sellers here, actually sell football? Okay, because that's what we did in 2011. So we opened up our store to other professional sellers. 2012, then we really started to hit it off in terms of more categories. So baby, health and beauty, cooking and dining, even more categories, jewelry and watches, bags and accessories, and even this year we did something with children's clothing. So for search, this you can understand that it means something. So in 1999, if you search for Tarzan, you would get books of Tarzan. When we started adding toys, you get toys about Tarzan. But when we started adding health and beauty, which has some erotic products, we also started getting Tarzan dildos. So if your kid is searching for Tarzan, you might also get those kind of products on the first page. So thinking about search became much more difficult when you add these kinds of products to your shop. So some numbers. We have over 11 million available products. We have 6.2 million active customers. So this is a bit of a marketing slide, but 50% of all online shoppers do it at Bol.com. We're the #1 brand associated with online shopping, and we have a decent brand awareness in Belgium as well. It's increasing. So when we're talking about search and browse, well, what is search and browse? Well, we define it as the exact match between what the customer wants and asks and what we offer. So customers usually come at our website and state a very generic query. I want a laptop. You have a kind of laptop. What does it need to do? So the exact match between what the customer asks for and what we offer. And to put it very blunt, search is free text search, browse is just clicking through your website. That's how we define search and browse. Okay, a bit more into detail about the number. So the exact amount is somewhere near 11.2 million available products and 12.4 million non-available products. And for search, it's also good to know the structure of these documents. For books have about 50 attributes: title, number of pages, etc. But for more complex products like a washing machine, you can think of at least 200 to 250 attributes that are relevant for a washing machine, and that are also relevant for search. over 1100 aggregations. Does everyone know what I mean with aggregations? It's basically the left side on this page, and you can click to navigate through the stuff. So we have in total over our entire website over 1100 aggregations. And when you search, we search, when you look at the main page, we search through 59 attributes. So it's not a Twitter feature searching through. You're searching through a lot of data, through 11.2 million products. We get to that non-available, so we have 12.4 non-available products. And that's that on the bottom left. That's that. So if you can't find something when you search for something, click on that one, and you might find it. All right, 20 million offers. Maybe this is a good example. So we have products, but as I mentioned in the beginning, we're not the only sellers. You can sell it if you have it, if you bought it at home, you want to resell it, or if you have other professional sellers that want to sell it through our platform. So we have one product, and we have many offers. And remember this one, because this one's coming back later. So we have 20 million, so on average about 2 offers per product. We have also 230,000 active Plaza partners. Plaza partners are professional sellers, which are about, I think, 11,000, and the rest is second-hand sellers. And this is, I think, for the month of March. So in the month of March, this is the amount of people that actually did something with our platform in terms of selling. So this is, for example, a professional seller page. Each professional seller gets its own page. So with a short description, some review information, and oh, this one is funny because this one doesn't have anything to offer, but usually you see a number here which states which amount of products this one is selling. In terms of updates, so all those Plaza sellers doing lots of stuff means about 200 to 1 million offer updates. So price changes, stock changes, availability changes, etc. And we also get roughly that amount of product updates. So people change content, product titles they change, or whatever. I think now is a good time to show you a bit about the general landscape of search at bol.com. So how does the data, where does the data start? So I just mentioned sellers, but we also have suppliers, like Centraal Boekhuis, provides us with a feed of all the books that we can sell through them. And we also have, of course, the Plaza partners. So all the stuff that they're doing, they go through some kind of gateway, which is another story at all. But that is split up into 2 parts. So we have content and we have offer. So content is, of course, product information, type, etc. Offer, price, availability, and stock information. So that's the updates that are coming from outside the company. But we have also stuff that comes from inside the company. We have forecasting inventory. So for fashion, it's good to know how much you want to have on stock for the coming summer. We have crawlers. We'd like to know what our competitors do. Who doesn't? So we need to know. How are the prices for the products that we sell as well. We also have product specialists and merchandisers who use our internal tooling to update content and to update offer information. And all that information is brought to our service. So we have a service architecture, which I'll come back to later. But for this discussion is PCS is a product and content service, and we have an offer service. And all that information comes into our search and browse engine. So our search and browse engine gets hit by all those updates, like I said, like 1 million updates a day offer and 500,000 content updates a day. But we also have our internal site search specialist. And they continuously monitor how do people search, can they find what they're looking for, and if they can't find what they're looking for, then we need to tweak something. Synonyms, so people are, this thing from Belgium, we have magnetrons, and in Belgium they call them microgolf ovens. Yeah, but if you're looking in Belgium for microgolf ovens, you couldn't find anything because we didn't have that synonym yet for magnetrons. So that's what site search specialists do. We also have two Hadoop jobs to determine our search rank. So our search rank is based on sort of the click behavior of our customers. So how much time has a customer seen a product, put it in a basket, bought a product. So we get all that information together, do some kind of logic with it, and so for each product it gets a sort of search rank which is used for the sorting and the results. And we also have the wisdom of the crowd of the facets. So that's I'm sorry, I sometimes use facets and aggregations, but they're the same in this discussion. So the order on the left side of your navigation is based on wisdom of the crowd. So if a lot of people within, for example, laptops click on brand, use brand, then brand will be on top, and other ones will drop down. But this also means that all this information is updated continuously and continuously hammers our search engine. And this is one of the scalability issues that we're dealing with. All those updates, and how do you handle them? How do you handle them real time? And how do you handle them performantly so that the systems don't go down? And in terms of number of requests we got, I think it's about 3,000 requests a second during the peak. So this is a bit about the scale that we have now. But when you're talking about new solutions like search, etc., so what are you scaling for then? Well, scaling for, and that doesn't mean that we actually could have that amount, but it's something you want to scale for. 50 million products, 200 million offers, 2 to 3 million offer updates a day, and about 5,000 requests a second, and each request should be sub 150 milliseconds. So that's the scale that we are talking about. So that's the scalability in scalable search. Is that clear so far? So what's the tool we're using now? What's Endeca? Does any, who knows Endeca? Has heard of Endeca? Of course. Okay. Well, of course, when you have Oracle who bought Endeca, like they do a lot of other stuff in companies. So Endeca, we've been using it for about 9 years. Is that right? 9 years? Sort of. Right. So what is Endeca? Well, yeah, this is a sort of a one-liner. It's a search engine with a super cache and a built-in navigation engine, including tooling for merchandising purposes. So, one question, who knows about ElasticSearch? Yeah. Oh, that's good. So what I mean with the built-in navigation engine, when you're programming with ElasticSearch, you have to tell it query time and which aggregator. With Endeca, you have a tool with which you configure beforehand which aggregations you want to show at which place. So when the index is built, I'll talk about that later, it does it all for you. So the entire navigation engine is already set. You don't have to program anything. Just search and you get back complete state. So about Endeca, there's a lot to tell. So I'll first start with how does the index get built. So the index is about these 5 steps. So we have an extraction process which gets some data from other systems that it needs. It does the transformation of that data to prepare it to actually be usable by our search engine. And then we have the forge and the DGIJs. Those are specific Endeca processes. So the forge gets the data from the data source, sort of forges that data and prepares it. And the DGIDX process actually builds the complete index. And the last part, the restart, is basically if you have an index, then you have to push it to the slave nodes, as we call them, and then restart those slave nodes. But we also have a challenge here because this is the amount of time it takes for each step. So it extracts, it's 20 minutes, but the transform step is 3 hours. But the fortunate DGIDX, it's almost 5.5 hours. So that's quite a lot. And the restart takes 30 minutes. And I believe a few years ago we were actually getting to about 15 or 16 hours to completely build an entire index. So we put a lot of effort into it, to, especially for those steps to be quicker. Adding new hardware also meant that one could get quicker, but the Forge is, for example, a single-threaded process. So yeah, getting over 11 million products and all that information indexed, yeah, takes some time. And remember, it also builds a navigation engine, so it's not with Elasticsearch of putting stuff in there as fast as possible, but also it does a lot of stuff under the hood. But this is building the index. So as I've said, we have a search-oriented architecture. We have about more than 50 services. One of the services is about a search and browse engine. So our service, so this is the Endeca index, which is implementation, and we abstract that through the shop find service. The shop find service is a Java service, and it is used by consumers. So consumers like our web shop, our open API, and our feeds use that service to get information out of Endeca. But the shop find service isn't just simple as sort of an abstraction layer over our search engine. It does more. So who does what? So the Endeca does matching and ranking, sorting and navigation, what you expect from a search engine. But the shop find service is quite a big service in the term that it does a lot of logic. So it does EN and ISBN recognition. So if you just type an ISBN, it can actually recognize that it's an ISBN. But it also does search flows. And what is, for example, search flow? If I look for, let's take the Tarzan example. It first looks at if the product is, if there's an exact match for the term Tarzan. And Endeca gives you back 0 result because, for example, there's nothing to match. And what the search flow then does, okay, let's do it again, but do a sort of a fuzzy matching. Okay, if I don't get anything back, okay, let's do a exact matching on products that are not available yet, etc., etc. So there's a complex flow engine behind it to help the customers better. And of course, we have what it also does is reordering the results. So what I mentioned earlier, that we have a Hadoop job that is about the order of the navigation, but the shop find service actually does that work. So it gets back a result from Endeca, picks up the navigation, looks at wisdom of the crowd, and does some resort. All right. So get into Elasticsearch. So why Elasticsearch? Well, a few reasons. Scalable solution. That is always something that we need. And not only from a technical standpoint, but from a financial standpoint. Like Oracle is not the cheapest. Not the cheapest. Let's just keep it at that. But we also think it can improve our search, especially personalized search. So what we did a while ago was within our game shop, if we knew that people bought a lot of, for example, Xbox games, and they were searching in games or just browsing in games, then we pushed products with Xbox tag platform to the top. And that worked really great. But if you want to have that at scale, Endeca doesn't perform at that scale. We did that a while ago, and I think it was 4 years ago. We actually did the first proof of concept, but it almost brought down the site because it was so slow. Yeah, so you have to know a bit more about insights of Endeca, but it was really slow at performance. But improved search as well, because you have a lot of influence on how you search, and Endeca itself is a black box. So you get some knobs, but yeah, spell correction, etc. It's sort of tricky. It's tricky in general for search, but we think with Elasticsearch you get more tooling. This one is, I'm personally very, this one is one of the key issues that I think is worth it. Flexibility through APIs. Someone mentioned, I believe Roland, he's one of the IT architects as well. And he said, yeah, well, have you ever tried to install Endeca on your laptop? No, don't even go there. If you just have Elasticsearch, you unzip it, you start it, and you have actual engine that does something for you. And everything you do, you can do through the APIs. Creating an index is simply as put and then your index name, and then you have an index. Don't even go there with Endeca. Real-time updates. So what I've I forgot to mention before. So we have the baseline, building the entire index. But we also have a batch process that does a partial update. But it's also a batch process, and it takes 3 hours for a batch process. And it can only do like 1 million offer updates. Or 200,000 offer updates at one time. So at the end of the day, you might have 3 or 4 of those batch runs, but you're not completely where you want to be. So one of the things we really like about ElasticSearch is the ability to do real-time updates. And real-time for us is 15 minutes. So it's not sub-second, but if an offer is updated within 15 minutes, because of the price change, that would be good enough. There are some other purposes as well. But we also think it's a solution for a product offer problem. So as I mentioned in the beginning, we have 20 million offers, and we have 11.1 million products. You have plaza sellers, you have second-hand sellers, and each and every one wants to sell their product through our site. But what is that solution then, or what is that problem? So what is it? So the current situation, and the screenshot is a bit old. So what you see here is 2 products within this price range, 15 and 27 euros. So what you see here is the price, but you can also see that there are other offers from other people which are cheaper. But this is my filter. I said, hey, until 24 euros. But why isn't this product showing up? It has an offer that's below 24. So what we're actually doing is, because of the way we implemented things, is we're excluding relevant offers for customers. And the reason is, our index is so that we can only use one offer. We call that the best offer. So we have only one price, one availability, and availability, I mean, this is offer-related facet. It's only based on one offer. But yeah, there are lots of other people that are selling this thing. So why does it get deleted? Well, yeah, because we can only use one offer. But that's what we wanted to do with ElasticSearch. We would really like to index all offers so we can get our customers the best experience possible. But that means something. From a website perspective, sorting on price becomes different. So you don't have to sort just on the best price, but you have to sort on all offers, for a single product, but actually for all offers within that result. So you have 444 products, but they might contain about 800 offers, for example. So you have to sort on those 800 offers, not just on that single offer. The price refinement, and this is a tricky one. We call this the roll-up, sort of a family thing. So you have an Apple iPod Touch, MP4 player, and these products are almost the same except for the color. And what you don't want for the customer is have all those products that are basically the same but a different color. You mentioned just like this one, because it's sort of redundant information. So we want to have a functionality which is called the roll-up. So if you sort on price or you refine on price, then you have to do it on that family as well. Another thing is that the product is new or second hand. That's an offer-related issue, offer-related refinement. Leeftijd. Sorry. This one. And also this one. Which articles are not available. And Belgium, Netherlands. So give me a product, give me a phone, which is only available in Belgium, second hand, between the price of 50 and 60, and I want to have it delivered before Saturday. We can't do that, simply because we don't have all the offers. That's what we want. So I hope you appreciate the complexity of the problem that we're trying to solve. So the experiment, now actually the fun part. So what is the challenge that we want to solve? So we have an hierarchical data model, and it's more complex than this. For example, we have a product family above products, but we also have multiple sellers. You can all model that, but for this problem we really wanted to model just a product and the multiple offers. But the challenge also is, yeah, that's nice if you want that, but how do you do that with a combination of the amount of searches, like 3,000 requests a second, and all those data changes, a few million updates a day. And also the complex requirements, what I just shown you means something for your queries that you have to build up. Those are really, can be really complex. So, yeah, we have to look at ElasticSearch and, okay, what does ElasticSearch offer you in terms of modeling? So there were general, roughly 5 ways of modeling information. You could do a document style, but see the offer as the main document, and within that offer, index a product. Which means that these could be 2 different offers with the same product. Then you have the nested model, which is you have a product, which is the document, and you have the offers, which are also documents, but they can only be found within that product. And you have the parent-child. So you have a normal product, a normal document, and these are also documents, and they have a relationship between each other. The benefit of this one would be, yeah, updates are really easy because you only have to update this one. Updating this one means updating the entire thing. And you have, which is, this looks a bit the same as this one, but it's different because in this case you don't exactly model them as entities, just as fields. And this is something we have now. So best offer pre-selection, which only uses one offer out of many. So our challenge was, okay, how do you find out which model fits our scale? So what do we do? Well, we started with the assumption that if you really want to test this up front, you can't start with a few hundred documents. You have to start at scale. So what we did is we used Node.js. What we built is basically lots of data in lots of different ways. So what we did is create the data with nodes, Node.js script. We created products, just some random nouns, and some mock data, but it's not simply mock data, it actually resembles our data, but it's for testing purposes, it was easy to do some mocking. And we have the offer data. About, I think, half of the products have no offer, and half have between 1 and 4 offers. Some kind of realistic assumptions. So what we did is build those files, and actually index them. And what we had at the end, so this is a screenshot of the head plugin of ElasticSearch, most of you know that. So at the end we have 9 indices with which you can test. So we have an index with 1 million for nested, 1 million for parent-child, and 1 million for document. And we have the 10 million for all those 3, and we have the 100 million for all those 3. So with this setup, we think, yeah, okay, we can actually make a really good guess, or really good guess about which model would fit our needs the best. This is indexing in Elasticsearch. So what we find out is, of course, you might know that getting stuff into Elasticsearch is easy. So imagine Elasticsearch is the pool. And you want to get that data out of your source systems. It's like having a sort of a hose trying to fill the swimming pool. So the bottleneck usually is the source system. try to get, I'm doing a proof of concept now with getting information out of Oracle or something else, and for this we actually found out that, yeah, if you index the data from the files, the reading of the files was slow. It's not indexing in ElasticSearch. So actually this is more ElasticSearch. ElasticSearch is the tunnel. Even with so much data in there as fast as possible, the bottleneck is usually your source system. That's one of the lessons learned. So about the use cases. Yeah, it's nice that you have those nine indices, but yeah, what are the queries that you're testing? Well, we have 4 use cases. So our first use case is a simple search. So we use a word in the title, order it by relevance, and we display the products based on, or we display products, and we want to display the cheapest package. And we want to aggregate on the category, books, electronics, etc., but also on seller ID, which is related to the offer, price, and the offer delivery code, so the availability of the offer. So that's the use case A. Use case B, actually filter on the delivery code 0, so if it's available or not. But then you have to actually display the correct cheapest. So if you have a product which has 10 offers, 6 are available, yeah, which of those 6 are you going to display? And also do an aggregation of category, and aggregate on the correct order seller ID, correct offer price, and correct delivery code. Use case C is we actually sort on price, so the lowest price high, which means order by lowest price, show the cheapest, the products with the cheapest offer on top, aggregate on the correct offers, seller ID, price, and delivery code. And the last use case, which is a bit more difficult to explain, but it's the roll-up function like I just showed you. So not just get those products that match the title, but also roll it up, so that you actually can display it in the way that we want it. So testing. This one was, yeah, that one was really, really nice because at some point, and then I did the testing with another consultant, Anne-Veling, you might have heard of him. And we actually sat with our own laptop and tried testing it, and we got funny results. Our results sort of were different. So we started creating those queries, trying to see if we can actually create actual queries in a sort of JSON format and actually fire them against all these indices. And we got back funny results. And for example, this one, the tricky one with this one, if you index offers as your main document, and within that offer you have the product, then the number of results you get back is way higher than you expect. And why is that? Because the numbers we show on the website, based on the number of articles found, is based on products. But your index is based on offers. So you have to sort of, okay, I found a set of offers, but then I have to sort of aggregate on the product ID again. So that's we found all sorts of weird cases, which was fun. But in the end, we got it working. The testing, we did that, and this is basically the result. So what you see here is the runs. So we did a run on the 1 million and on the 10 million, and the 100 million was sort of the same. This is the request time in milliseconds, the average request time in milliseconds for, I believe we did 1,000 or 10,000 queries. These are the use cases, A, B, C, and D. This is the document, nested, and parent-child relationship. You might be thinking, hey, why don't I see parent-child? Because we couldn't actually get the sorting on price with parent-child working. Doesn't mean that's not possible, but with the time we had, we couldn't even get that to work. But in general, you see the same picture. So for us, nested was overall the fastest. And you can actually see that the document with offers was almost always the slowest. This one is a bit different. This is the roll-up of family. So this, yeah, but the nice thing is offers are already sort of a relationship with each other. So the roll-up was easier. And for the nested, this was tricky. So it doesn't mean that we're done. But for our purpose, we proved that nested style was best for our case. And this one, yeah, we still have to tweak. Because bothering the customers with, for example, with queries that take almost 2 seconds, yeah, that's not what we want. So this is pretty good. And it was done on a cluster of 12 nodes. And they all had 32 gigabytes as RAM. But we didn't do any tweaking of queries, any tweaking of OS or anything. So there's lots of improvement to be gained. But this was the outcome, and this was actually helpful in the choices we're making now. Is that sort of clear? No? So conclusions, parent-child has its limitations, especially combining cross. Difficult queries are just difficult with parent-child. Documents not as fast as we expect. That's a bit of a technical term because of the top hits aggregation. So I mentioned you get all the offers, but then you still have to aggregate on the product. But we also saw that ElasticSearch scales predictably. So even the results we just saw is the same for the 100 million. So for us, nested was the best solution. I'm not sure if you guys are doing anything with modeling or ElasticSearch, but I think one of the lessons learned is that testing for the scalability of what you're doing should be done up front. Do some fast iterations. I mean, yeah, you could look up Stack Overflow, find out what's the best solution for ElasticSearch, but it's always use case based. Try it yourself, do it yourself. It's not that easy, it's also quite a lot of fun. So that was about the experience that we did. I have 2 slides. First is about migration. Are we actually moving to Elasticsearch? Yeah, we still have to prove some stuff. So we did that experiment, but that was only to get us forward in deciding which model we need to do. But I said in the beginning, personalized search, real-time updates, getting everything working to actually prove it to management to okay this and actually prove the value of this, and that's a whole other ballgame. So we're actually going forward with this in terms of proving parts functionality I mentioned, and doing that in sort of a pressure cooker way to prove to management, okay, this can actually work. That's something that we're doing now, but it takes time. It takes a lot of effort. And we also have some other stuff to do, fortunately, because I really like this. But if we actually get the go to do this, migration is, you can imagine it's not that simple. One of the main issues that we have here is if you look at our URL, you see bol.com/nl, blah, 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 and you you often see /n with a number. That n with a number, that's Endeca specific. So we sort of leave the actual technical implementation to our URLs. So if you go to Elasticsearch, with no clue about what n or the number is, you would lose your entire SEO value. And we're pretty good at SEO, but that's not something that we want. So you actually have to figure out how you can migrate the current URL, or maintain the current URL, and somehow replace your search engine, while still having customers buy some stuff and actually finding them. So the idea is to move slowly and start with a small shop. Start with a small shop, see if you can figure out if you can match the URL that people are expecting. So do some kind of translation of what Endeca used to have to the Elasticsearch model, and actually bring that live. And before you actually do the rest of the shop, actually prove that customers are having a better search experience, better offer experience, but just for that shop. But that means that if we, for example, if we want to do that for games, Okay, but how would you do that? If I'm on the home page and I search for Far Cry, okay, then I get a general search result. But where do I get the search result from? Do I get it from ElasticSearch or from Endeca? Okay, let's say we get the search results from Endeca. Then I click on games. Yeah, but do I go then to ElasticSearch? So there's lots of challenges that we need to tackle. But yeah, that's also the fun part. This is sort of management. We have Endeca now, and one of the really cool things about Endeca is it has only failed us once or twice in the past 9 years, from an operational perspective. So, sort of, you can basically say it's never gone down. It's stable as hell. It's also fast, 3,000 requests a second for a peak season. That's pretty good. Or we can go even higher. So, from an operational perspective, it works fine. So then, as a manager, you can say, hey, it works. Why are we touching it? So again, we also have to prove that it can work and that it will work. And of course, that customers would actually like to see this go live. Not a less search, but a better search experience. So that's still the nail biting. So we have to convince a lot of people that ElasticSearch can be better and is better. But yeah, the outcome could also be that we can't prove it enough. So that's very realistic. We can't prove that it's that much better to actually put all that effort into ElasticSearch. But I'm very hopeful. And we do some other cool stuff with ElasticSearch that hopefully you'll see in a few weeks on production as well. So keep your eyes open. I think you know what I mean when you see it. But that's what we're doing here. So, yeah, I had that slide. I did this slide a few weeks ago, and I saw some fake faces like, what is this slide? So there's a question. Are there any questions?
How do you are going to compare the prices of the if you're doing things like A/B testing?
Yeah, we do some kind of A/B testing. Yeah. So it's creating an A/B test and having people, a set of people go into that A/B test and see how the conversion goes for that store. So that's one of the difficult parts. Is you can't simply say, okay, for games you go to ElasticSearch. No, you can only go to games for a certain set of people because you have to compare the results somehow. But we have tooling for that, and we do that all the time. But that's how we're probably going to do it. Yeah. All right. That's it.